Hello Kearns High School, and welcome to today's Math Self-Start. Today we're going to be talking about combining like terms. It's like comparing apples and oranges. Some terms are alike and some are not, and so it's our job to be able to tell the difference. So how would you be able to keep track of the number of apples and oranges in a fruit basket? Well, what you would do is take all of the fruit and sort it, taking out all the oranges and counting them up, and taking out all the apples and counting them up. In this example, we have 12 oranges and 8 apples. The 12 and the 8 are what we would refer to as coefficients because they tell us how many oranges and apples we have in our fruit basket. In math, the fruit basket gets replaced with a term basket. And our job is to be able to sort through all these terms and combine all the ones that go together. So to be able to figure out which ones go together and which ones don't, let's take a look at this basic example. Let's compare the number 1 compared to x and versus x to the second power, commonly referred to as x squared. Let's go ahead and take a look at a visual representation of each one. The number 1 is represented by a 1 square. Its height is 1, its width is 1, and 1 times 1 makes 1. The x is represented by the green rectangle. Its height is 1, its width is x, and 1 times x makes x. Now take a look at the next picture here. With an x squared, the x squared has a height of x and a width of x, and x times x makes x to the second power. Now what if we compared 2 versus 2x versus 2x squared? Well, what we would get is 2 1 squares, 2x rectangles, and 2x squared squares. So that's a visual representation that we're going to use to help us as we're combining like terms. Now one thing to remember, this is a common mistake. 5x plus 5 does not equal 10x, and now we can see why. 5 x's look like this. 5 1's look like this. And when we add 5 x's and 5 1's together, we do not make 10 x's. What we make are 5 x's and 5 1's. So the 10x is incorrect. What we should have in place of the 10x is 5x plus 5. They just remain separate. So now let's practice. Take a look at this polynomial. We have 3x squared plus 4x plus 5x plus 3 plus 2x squared plus 2. And here we have the visual representation of each term. What we're going to do is put like terms together. So x squareds grouped with x squareds, x's with x's, and the 1's grouped with the 1's. Then what we can do is add up the coefficients of each of those terms. 3 plus 2, 4 plus 5, and then we add up the 3 plus 2. Our final result is 5x squared plus 9x plus 5. So let's review what all we need to do to combine like terms. Take a look at this example. The first thing we do is put like terms together in groups. So the x squared y terms go together in brown, the xy terms are grouped together in blue, the xy squared terms are grouped together in green, and we have one x cubed y term all by itself. Next, we count up the number of groups by adding or subtracting the coefficients. 3 plus 2 for our x squared y terms, negative 16 subtract 13 plus 2 for our xy terms, 5 plus 4 plus 11 for our xy squared terms, and again we have the x cubed y all by itself. The solution is 5x squared y subtract 27xy plus 20xy squared plus x cubed y. So now it's time to do some practice. Pause the video to give yourself some time to combine all like terms. And our final result is 12a squared plus 5a plus 5. Let's take a look at one more practice problem. Pause the video to give yourself some time to combine all like terms. And we get 8a squared b subtract 2ab plus 4ab squared. I hope you've enjoyed today's math self-start, and we'll see you again soon.